All right, last video for chapter 3, the Atwood machine. Atwood was a pretty cool physicist, and basically what he did was he took two masses, one here, one here. He put it over a really, really well-built pulley. Okay, when the two masses were equal, and he let go of them, they would just sit there. If he would move it up, he would just move with a constant velocity up. Pull it down, move a constant velocity down. All right. And from that thought process, what he did then is he said, I want to calculate the acceleration of gravity using this Atwood machine. So he took two masses, one weighed a little bit more than the other. Okay. Put it on there. He held the string about a meter from the ground. All right. He measured it from the one mass, the heavier mass. All right. And then he pulled the small one down. So the heavy meter one was up here. The lower one down here was at ground level. When he let it go, it went like that. All right. It started to accelerate. All right. What he did was he took the height and the time for it to move. He was able to calculate the acceleration of that setup. And from that, he was actually able to calculate gravity. So let's look at what we have here. It says the Atwood machine. We were able to derive an equation for the acceleration by using force analysis. If we consider a massless, inelastic string and an ideal massless pulley, the only forces we have to consider are the tension force and the weight of the two masses, mg. To find an acceleration, we need to consider the forces affecting each individual mass. Using Newton's law, if m1 is larger than m2, we can derive a system of equations for the accelerated acceleration. Forces affecting m1. So we have m1 times gravity pulling down minus the tension in the string pulling up equals the mass of the times its acceleration. And then forces affecting m2 would be the tension pulling up minus its mass times gravity pulling down, and that would equal the mass of 2 and its acceleration. Now, these two accelerations, this one and this one, should be the same because they're attached on a string that is non-elastic. So by adding the two previous equations together, we get m1g minus m2g equals m1a plus m2a, and at last we get a, the acceleration of the masses is equal to gravity, 9.81, times mass 1 minus mass 2 over mass 1 plus mass 2. All right, some interesting algebra there, but it's not too bad. So conversely, the acceleration due to gravity g can be found by timing the movement of the weights and calculating a value for uniform accelerated motion. All right, so the distance that mass drops, okay, let's say when he did the experiment in 1 meter, is equal to 1/2 acceleration times time squared. All right, so he times it, and then he came up with little a, okay? You put little a in here, all right, equals g, mass 1 minus mass 2 over mass 1 plus mass 2. Okay, you can use algebra to pull g out, all right, correctly. It can be useful to know an equation for the tension of the string as well. To evaluate tension, we substitute the equation for acceleration in either of the two force equations. Okay, so for example, substituting m1a equals n minus m1g, we get n is equal to gravity times 2 times mass 1 times mass 2 over mass 1 plus mass 2. The tension cannot accurately be found using this method due to the torque of the pulley. All right, torque is something we'll learn about later. But anyways, you get pretty close to it. All right. So this formula here you can use to calculate the acceleration of the two masses moving. All right. Um, if we gave you mass one, mass two, and using gravity, or you could say, hey, let's take this system to the moon, and we will drop it. We'll calculate A using kinematics of the 1/2 at squared, and then place A in here, and then just solve for G to find gravity. Oops, what happened there? There we go. So here's an example. It says use an Atwood machine. M1 is 4 kilograms, M2 3.5 kilograms. Find the acceleration of the setup and the tension in the wire. All right. So now this we're doing this on Earth. G is 9.81. Now you're going to have a homework question where you're going to be doing this. You're going to have a test question that will ask you to find gravity. So you have to do a little more manipulating on the algebra side. Okay. So A equals G, M1 minus M2, M1 plus M2. So you put this in, make sure you got your parentheses. So you got 4 minus 3.5, so that's a half on top, and then 4 plus 3.5, which is 7.5 on the bottom. Divide these out, multiply by 9.8. The acceleration will be 0.654 meters per second squared. It would move kind of slow. All right. The tension, which is on the wire, all right. Let's say we got a wire or a string that we're using and say, hey, we can only hold 40 newtons of tension. You can set this up and you say, yeah, it's going to work, all right, because it comes up to be 36.6 newtons, all right. So this is example of the Atwood.